How did they build in the Middle Ages without modern tools? You will be shocked by the methods they used.
Observe how the keystone distributes the load.
We look at the majestic cathedrals and impregnable castles that have come down to us from the depths of centuries and ask ourselves, how? How could people without electricity, hydraulic cranes, or laser levels create such masterpieces of engineering? Their world was one of brute physical force, wood, stone, and iron, but their buildings still amaze us today. We are used to thinking that progress is a linear movement from simple to complex, from primitive to perfect. But when it comes to medieval construction, this certainty begins to waver. Their methods conceal a logic and genius that we are only beginning to rediscover. They did not just build, they entered into a dialogue with the material, sensing its character and possibilities. Each stone, each beam was not just a detail, but part of a living organism that had to stand for centuries. Watch the video to the end, and you will learn the true price, expressed in sweat and incredible ingenuity, of simply building a roof over your head in the Middle Ages. What if I told you that absolutely everything you firmly believed about the primitiveness and backwardness of the medieval life of ordinary people is a profound misconception and untrue? We will begin our study not with the majestic castles of the nobility, but with the simplest, most common, and most widespread structure of that era, the ordinary peasant house, of which there were millions. It was here, far from royal ambitions and ostentatious luxury, that the true genius of the people for survival and practical construction from readily available materials was truly manifested. Simple peasants developed technologies that allowed them to build durable and relatively comfortable dwellings with virtually no money, using only local resources and the collective labor of the community. The basic philosophy and principle of the peasant house was extremely simple and rational: to make maximum use of what the land beneath their feet in a given area generously provided. It made no economic sense to transport expensive hewn stone hundreds of kilometers by cart when there was an abundance of accessible forest and clay deposits right nearby. A peasant house was not just a utilitarian structure for shelter, but an organic continuation and reflection of the surrounding natural landscape, a part of it. The house literally grew out of the local soil, using its gifts, and blended harmoniously into the environment without disturbing its balance. The so-called cruck frame, an extremely effective construction, served as the solid foundation for many traditional houses in densely forested areas of medieval Europe, such as England, Germany, and France. To do this, builders would go to a nearby forest and find two large trees with a natural arch in their trunks, carefully cut them down, and saw them in half lengthwise with a special saw. This resulted in two almost mirror-image curved halves of the same tree, which, when skillfully joined at the top with a cross beam, formed a perfect, sturdy A-shaped arch without a single nail. The natural shape of the tree was used to maximum effect, providing natural strength to the structure without complex processing. These massive wooden truss arches became the main supporting skeleton and foundation of the entire house, on which the rest of the structure rested. They were securely placed on a shallow stone foundation to protect them from rot, and rigidly connected to each other with longitudinal horizontal beams to form a frame.
This is where we bring the parts together, very gently now.
Yes,
It was a quick-to-build, material-efficient, and incredibly durable proven method of creating a reliable foundation for heavy roofs and walls. Such a frame could stand for centuries, supporting the weight of the roof and withstanding the winds, while its construction did not require special tools or high qualifications. The walls of a peasant house were a truly remarkable work of folk art, admirable for their resourcefulness and environmental friendliness. The space between the vertical beams of the wooden frame was carefully filled with a woven, flexible structure made of thin willow or hazel rods, traditionally called a wattle. This woven plant shield was then thickly coated on both sides with a thick layer of a special mixture of local clay, crushed straw, river sand, and domestic animal manure, the so-called adobe or daub, creating a solid wall. This technology has been used for thousands of years and has been perfected by many generations of builders. Such a multi-layered wall was incredibly cheap to build, practically free, retained precious heat in winter thanks to its thickness and porosity, and breathed naturally, effectively regulating humidity in the room without mold. In summer, such a house with thick walls was pleasantly cool even in the heat, and in harsh winters it was relatively warm with minimal heating. In case of mechanical damage, any section of the wall could be easily and quickly cut out and replastered by hand, using the same affordable local materials without hiring specialists. Repairs did not require significant costs and could be carried out by the homeowner himself in a day. The roof of the house was most often traditionally covered with dry rye straw or durable reeds from the marshes. Carefully laid in a very thick, dense layer, several tens of centimeters thick, using a special technology. Such a plant-based roof was not only completely waterproof when laid correctly, but also served as an excellent natural insulator, retaining heat.
It's getting late. We should get some rest.
When laid correctly and professionally with overlapping layers and regular maintenance and renewal, it could serve reliably for several decades without complete replacement, which made it economically advantageous. A thatched roof was also lightweight, which reduced the load on the frame of the house and did not require strong supports. The floor in the simplest and poorest peasant houses was usually earthen, well trodden to hardness, and sometimes covered with a fresh layer of clean straw for extra warmth, softness, and relative cleanliness. The windows in the house were deliberately made small and narrow to maximize heat retention and reduce heat loss, and were securely closed at night with wooden shutters to keep out the cold. Expensive glass was almost never used in the windows of peasant houses. It was an unaffordable luxury reserved exclusively for wealthy townspeople and the nobility. Instead of glass, oiled paper or ox bladders were sometimes used to let in light, but they were fragile and short-lived. Thus, a typical peasant house was almost entirely biodegradable and consisted exclusively of renewable natural resources without synthetics. It literally grew out of its native soil, using its gifts, and, in the event of prolonged abandonment and destruction, naturally returned to it over time without a trace. It was a perfect example of harmonious coexistence with nature in a closed cycle, born not from modern ecological ideology, but from harsh necessity and limited resources. Peasants could not afford wastefulness and used every available material with maximum efficiency, creating a sustainable building system. We would be very interested to hear your balanced opinion on this issue. What exactly do you think about this traditional approach to eco-friendly construction using local materials compared to modern industrial technologies involving concrete and plastic? Please write your detailed thoughts in the comments below. Are you ready to learn the truth about what lies hidden underground beneath every medieval cathedral? The foundation is the invisible part of any building on which everything depends. A mistake made at this stage cannot be corrected later and will inevitably lead to disaster. Medieval builders understood this better than anyone. They did not have ground-penetrating radar or soil analyzers, but they did have experience, observation skills, and techniques honed over centuries. Before construction began, the master builder carefully studied the site, determining the soil composition and groundwater level. The process began with digging a huge pit or trenches for the future walls. This was one of the most labor-intensive tasks, performed manually with shovels, pickaxes, and hoes. The earth was carried away in wheelbarrows or carried in baskets. The depth of the foundation depended on the scale of the building and the quality of the soil. For massive stone cathedrals, the pits could go many meters into the ground until the workers reached a solid, load-bearing layer, rock or dense clay. If the soil was weak and swampy, they had to resort to tricks. In such difficult conditions, for example, when building in Venice or Amsterdam, hundreds or even thousands of wooden piles were driven into the bottom of the excavation pit. Oak or larch was usually used, as the wood of these species does not rot in water. The piles created a solid foundation that evenly distributed the weight of the building on weak soil. The foundation itself was laid on the prepared base. It was made of the strongest and heaviest stone that could be obtained. The stones were laid dry or fastened with lime mortar, trying to minimize voids. The width of the foundation was always significantly greater than the width of the future walls. This created a stable base that prevented the walls from walking and cracking under the enormous weight. The rule was simple. The higher and heavier the wall, the wider its underground roots had to be. Builders also paid great attention to drainage. Special ditches filled with gravel were laid around the foundation to drain rainwater and groundwater. Excess moisture could erode the soil and weaken the entire structure, so it was combated from the very beginning. The quality of the foundation was a matter of honor for the Masons Guild. Not only their reputation depended on it, but also the lives of the people who would be in the building. Therefore, at this stage, no effort, time, or materials were spared. This invisible work and the tremendous strength laid in the foundation are the reason why many medieval buildings still stand today. But how did builders manage to turn shapeless boulders into perfect building blocks for walls? In the next chapter, you will learn how a medieval quarry worked. Here's what happens behind the closed doors of the mountains that you definitely didn't know about. Stone extraction was the starting point for any major construction project, its hidden but most important stage. In the Middle Ages, a quarry was a separate world with its own laws, technologies, and dynasties of craftsmen. It all started with a search. Master stonecutters could travel around the area for months, studying rock outcrops and looking for stone of the right quality. They were interested not only in strength and color, but also in the structure of the rock. Good building stone had to be easy to work with and have no hidden cracks. When a suitable site was found, preparations began. The top layer of soil and loose rock was removed from the site, exposing a monolithic stone layer. It was hard work carried out by ordinary laborers with pickaxes and shovels. The most interesting process was separating huge stone blocks from the rock massif. There were no explosives at the time, so the stonecutters used a simple but ingenious technique. First, they hollowed out a series of deep holes along the line of the future fracture using chisels and hammers. Dry wooden wedges were inserted into these holes. Then these wedges were generously watered. The wood, absorbing moisture, slowly but with incredible force expanded, creating enormous tension inside the stone. After a while, a crack ran along the entire length of the fault, and a multi-ton block separated from the rock with a dull thud. This method required patience and precise calculation, but it allowed them to obtain blocks of the desired size without damaging their structure. Sometimes, instead of wooden wedges, metal ones were used, which were driven into the holes simultaneously along the entire length. The separated blocks were too large to transport. Therefore, they were immediately split into smaller pieces right there in the quarry. To do this, the same method with wedges was used, or simply powerful blows with sledgehammers along pre-marked lines. The initial rough processing of the stone also took place on site. Special craftsmen gave the blocks an approximately rectangular shape, cutting off all the excess. This was done in order not to transport excess weight to the construction site. Transporting the stone was a separate and extremely difficult task. The blocks were loaded onto special sleds or large carts pulled by dozens of oxen. The journey from the quarry to the construction site could take weeks and required the construction of temporary roads and bridges. Working in the quarry was one of the hardest and most dangerous jobs. Stonecutters breathed in stone dust and risked being crushed by giant blocks. But it was their labor that formed the foundation of every castle and cathedral, transforming dead rock into building material. What I am about to show you will change your perception of working with wood. Wood was as important a building material as stone. It was used to make house frames, roof trusses, floors, doors, as well as complex mechanisms and scaffolding. The selection and preparation of wood was an art form. Carpenters went into the forest in winter when the sap stopped flowing in the trees. It was believed that such wood was denser, more durable, and less prone to rot and warping. They chose tall, straight trees, most often oak, which was valued for its incredible strength and resistance to moisture. The master could determine the quality of the wood, the presence of knots or internal rot by the sound of the axe. The selected trees were marked and left until the felling began. Felling was carried out using two-handed axes and large saws. First, a deep undercut was made on one side, which determined the direction of fall. Then on the opposite side, they began to saw the trunk until the tree began to fall under its own weight. After felling, the trunk was cleared of branches and bark right on the spot. The bark was removed so that the wood would dry faster and pests would not settle under it. Then the huge logs had to be transported from the forest to the processing site. To do this, they used either sleds or, if there was a river nearby, they simply floated the logs down the water. Floating was the cheapest and most efficient way to transport large volumes of timber. On the shore, the logs were caught and pulled ashore with the help of oxen and simple lever mechanisms. The next stage was sawing the logs into beams, timbers, and boards. To do this, the log was placed on high trestles. One sawyer stood at the top of the log and the second stood below in a specially dug pit, which is why his clothes were always covered in sawdust. They used a huge two-handed saw. The work was incredibly hard and required perfect synchronization of movements. The sawyer at the top set the direction, while the one at the bottom did the main pulling work, constantly surrounded by a cloud of flying sawdust. Before sawing, perfectly straight lines were marked on the log with a rope rubbed with chalk or charcoal. This allowed for the production of beams and boards with smooth edges. Although their surface remained rough from the saw, the geometry was accurate enough for construction. After sawing, the wood was stacked for drying. Drying could take several years, but it was necessary to prevent the material from warping and cracking in the finished building. Only after this long and laborious process was the wood ready to become part of the future building. But how were these massive beams joined into a single structure without a single nail? The basis of absolutely all medieval wooden structures, from simple peasant barns to the most complex multi-tiered roofs of majestic cathedrals, was an ingenious, centuries-old system of durable tongue-and-groove joints that did not require metal. Medieval carpenters and craftsmen brought this ancient art of joinery to absolute perfection and virtuosity through generations of knowledge transfer. They understood deeply from practical experience that metal nails and staples inevitably rusted over time due to moisture and were extremely expensive, while a properly made wooden joint with a precise fit only became stronger over time due to the shrinkage and swelling of the wood. As the wood dried and shrunk, it compressed the joint even more tightly, making it virtually inseparable and increasing its strength with each year of service. The most common and versatile was a basic joint called a half-tree notch, which was used everywhere in construction. In two beams to be joined, exactly at the point of their intersection at a right angle, half the thickness of each beam was carefully cut out with an axe and adze, creating flat surfaces. When the processed beams were placed on top of each other with these notches, they formed a perfectly flat, uniform plane without protrusions and were firmly mechanically connected to each other by friction and mutual pressure. This joint was simple to execute, but very reliable for most structures and could withstand significant loads without deformation. For a strong connection of massive beams at right angles, for example, when assembling the vertical walls of a half-timbered frame house, or when creating frames, a more complex tenon in an open groove connection with a precise fit was widely used. A rectangular protrusion of a strictly defined size, a tenon, was skillfully cut out at the end of one beam, leaving it protruding. A corresponding recess, or groove, was carefully carved into the side surface of the other beam with a chisel, checking the accuracy. The accuracy of the fit was critical to the strength of the entire assembly and required the experience and patience of the craftsman. The carved tenon was inserted tightly, with force, into the prepared groove, creating a strong corner joint capable of withstanding heavy loads. To make the structure even more reliable and prevent the joint from coming apart over time, the connection was additionally secured mechanically. To do this, a through round hole was carefully drilled with a drill bit in the already assembled and fitted joint, and a special wooden nail, a dowel, was hammered into it with force, wedging the joint from the inside. The dowel passed through both parts, firmly fastening them together and preventing them from coming apart even under heavy loads. Nails were traditionally made from hard, durable woods, such as oak or ash, which did not split. They were slightly conical in shape, tapering towards the tip, which allowed them to be driven very tightly into the hole with tension, creating a wedge. This clever connection not only held the beams together securely without loosening, but also allowed the entire structure to have a small amount of natural mobility and flexibility, which was critically important during the inevitable settling of the building in the early years. A rigid metal connection could have caused the wood to crack during shrinkage, while the dowels allowed the wood to work. For more complex and critical structural joints, such as when attaching sloping rafters to load-bearing horizontal roof beams, hidden and more complex joints were used, requiring skill to make. One such classic joint was the famous dovetail, considered a sign of high craftsmanship. In this case, the tenon had a characteristic shape of an expanding trapezoid, truly resembling a swallow's open tail, and was inserted into a groove of the same complex shape with perfect precision. Carving such a joint by hand was very difficult and required many years of experience and a steady hand. This ingenious joint was self-locking due to its geometry and worked only in tension, preventing the parts from coming apart. Due to its shape, it was practically impossible to disassemble it without destroying or splitting the wooden parts completely. This ensured the highest strength, reliability, and durability of the entire structure for centuries, which was critically important for critical components. The dovetail was used in the most heavily loaded and important joints, where failure was unacceptable. All the numerous grooves and tenons in the beams were cut and carefully hollowed out exclusively by hand using a set of tools: axes, chisels, sharp gouges of various widths, and special saws for precision work. Precise markings were made using wooden squares for right angles and straight edges for parallel lines, checking each dimension. The work required incredible precision of eye and hand from an experienced carpenter. Even a gap of a few millimeters could critically weaken the entire joint and lead to its premature destruction under load. The skill of a carpenter was determined precisely by the accuracy of the joints, which could only be achieved after many years of practice. Assembling the wooden frame of a house was like working with a giant three-dimensional construction set made up of many parts, requiring the coordination of a team. The frame elements, carefully prepared and fitted on the ground, were lifted up with blocks and ropes and joined in a strictly defined order according to the master's plan. Each connection was carefully thought out and executed with such precision that the forces within the entire structure were distributed evenly across all elements, without overloading individual parts. Understanding the distribution of loads was intuitive, based on the experience of generations of builders. It is thanks to this high art of carpentry and the skill of the builders that we can still admire beautiful half-timbered houses that are 500, 700 years old, and the giant wooden roofs of Gothic cathedrals that have survived the centuries. These impressive structures are not just a chaotic pile of beams and boards, but a unified, well-thought-out, breathing living organism made of wood. They are held together not by numerous nails and metal, which are subject to corrosion, but by the pure geometry of the joints, the laws of physics, and the highest craftsmanship of medieval carpenters, passed down from father to son. Are you ready for the shocking truth about how medieval skyscrapers were built? As the walls of a castle or cathedral rose higher and higher, builders faced a major problem: how to get multi-ton stone blocks and massive wooden beams to the top. The solution to this problem was one of the most impressive achievements of medieval engineering. In the early stages of construction, simple earthen ramps or embankments were used. As the walls grew, the embankment was also filled in and lengthened, turning it into a gentle road along which oxen could pull sleds with stones to the top. This method was effective but required a huge amount of earth and labor. When the height became too great, lifting mechanisms came into play. The simplest was a conventional winch, a log with handles onto which a rope was wound. This device allowed several workers to lift small loads. For really heavy blocks, a more serious machine was needed, and that machine was a large lifting crane with a squirrel wheel. It was a huge wooden structure resembling modern cranes, but with one key difference. The crane was not powered by a steam engine or electricity, but by human muscle power. One or two huge wooden wheels, several meters in diameter, were installed at the base of the crane. Workers walked inside these wheels like squirrels. Stepping on the internal crossbars, the people turned the wheel with their weight. The wheel, in turn, rotated a drum via an axle, onto which a lifting rope was wound. This system, which worked on the principle of a lever, allowed 2 or 3 workers to lift loads weighing several tons to a great height. These cranes were installed directly on the walls under construction or on the upper tiers of scaffolding. They were collapsible, and as the building grew, they could be moved higher and higher. The work inside the squirrel wheel was monotonous and exhausting, but it was this work that made it possible to erect the walls of Gothic cathedrals. A system of blocks and pulleys was used to position the load accurately. Not only did it increase the lifting force, but it also allowed the masons on the scaffolding to use ropes to precisely guide and install the block in its place. The master on the scaffolding signaled the crane operators with flags or his voice. These giant wooden machines were the pinnacle of construction technology of their era. They were slow, creaky, and completely dependent on human endurance. But it was they that allowed the people of the Middle Ages to reach for the sky and build buildings that still amaze with their height. But what held the stones in these walls together, making them a monolith? The strength of masonry depends not only on the quality of the stones, but also on the mortar that binds them together. Medieval builders did not have modern Portland cement, but they created their own surprisingly durable binding material. The basis of this mortar was lime. The production process began with the extraction of limestone. Like building stone, it was mined in quarries. The limestone then had to be burned to turn it into quicklime. For this purpose, special furnaces were built, similar to large stone wells. The furnace was tightly loaded with pieces of limestone and firewood. Then the firewood was set on fire, and the burning process could continue for several days at a temperature of about 900 degrees Celsius. After burning, the limestone turned into fragile, light pieces of quicklime. It was a very corrosive and dangerous substance that had to be handled with great care. The next step was to slake the lime. Quicklime was poured into water in special pits or vats. A violent chemical reaction began, releasing a large amount of heat, hissing and steam. The result was slaked lime, or pushonka, a plastic paste-like mass. This lime was left to mature in pits for several months and sometimes years. It was believed that the longer the lime matured, the higher the quality and strength of the mortar would be. During the maturing process, it was stirred periodically. To prepare the mortar, a filler was added to the slaked lime, usually clean river sand. The proportions of lime and sand were carefully selected depending on the purpose of the mortar. The mixture was diluted with water to the desired consistency. This lime mortar had an interesting property. It hardened very slowly. This was both an advantage and a disadvantage. On the one hand, it allowed bricklayers to take their time and carefully lay the stones, adjusting their position. On the other hand, fresh masonry was vulnerable and required time to gain strength. The mortar hardened as a result of a reaction with carbon dioxide from the air, gradually turning back into limestone. This process could take decades, but in the end, the masonry became monolithic. It was thanks to the quality of the lime mortar, which only became stronger over time, that the walls of medieval castles and cathedrals were able to withstand the test of centuries. This simple but reliable material was the true liquid stone of its era. No high-rise construction is possible without scaffolding. In the Middle Ages, scaffolding was not just a temporary aid, but a complex engineering system on which both the speed and safety of work depended. It was the fifth wall that grew along with the building. Medieval scaffolding was made exclusively from wood. Long straight poles were used, which were fastened together with ropes. Nails were rarely used for this purpose, as rope connections were more flexible and allowed the structure to be easily dismantled and rebuilt. There were two main types of scaffolding. The first, simpler type was an independent structure that rested on the ground and stood at a certain distance from the wall. This type of scaffolding was used in the construction of buildings that were not very tall. For the construction of tall cathedrals and castles, a more complex, so-called plug-in scaffolding system was used. It was integrated into the wall itself. This method saved a huge amount of wood and created very strong and stable structures at great heights. The principle was simple. During the masonry process, bricklayers left square holes in the wall at equal distances from each other. The ends of horizontal beams, called puttlogs, were then inserted into these holes. The outer ends of these beams rested on vertical posts, and the entire structure was reinforced with diagonal braces for rigidity. Wooden decking was laid on top of the putt logs, allowing workers to walk on it and move materials. As the wall grew, the lower tier of scaffolding was dismantled and moved upwards. This system was very effective. The scaffolding was firmly attached to the wall, which prevented it from collapsing. In addition, it allowed construction at any height by simply adding new tiers. After construction was completed, the scaffolding was dismantled, and the wall openings were either filled with stone or left open. In many medieval castles and cathedrals, we can still see these neat rows of square holes, silent witnesses to how the building grew. Working on such scaffolding required great skill and a fearlessness of heights. The platforms were narrow, and there were no railings or safety harnesses. It was a dangerous world where every step had to be carefully calculated. It was this complex system of wooden ropes that allowed craftsmen to climb higher and higher, transforming piles of stone into architectural masterpieces. Without this temporary but vital structure, the creation of Gothic cathedrals would have been simply impossible. Who exactly was in charge of this incredibly complex process of constructing grandiose buildings? In the Middle Ages, there were no professional architects in the modern sense of the word, with higher education and diplomas. The person who simultaneously designed the building in his mind and directly supervised its practical construction on site was called a master builder or chief mason, Magister Operis in Latin. This position required a unique combination of theoretical knowledge, practical experience, and organizational skills, which was rare. This outstanding person was not an educated theorist detached from reality, but a practitioner of the highest class with decades of experience working with materials. He usually began his long professional career as a teenager as a simple apprentice mason in a guild, methodically passing through all the stages of the strict medieval hierarchy of craftsmanship. And over time, thanks to his exceptional talent, hard work, and accumulated experience, he was able to lead the largest construction project of his time, a cathedral or castle. He knew absolutely everything about the properties of stone and wood from many years of practice, how materials behave under load, how to process them correctly, and what their weak points are. This knowledge was not gained from books, but through years of working with materials by hand. In the Middle Ages, building design did not take place on paper at a desk, as it does today with computer programs. Although some preliminary sketches and simplified plans were indeed made on expensive parchment for the customer, these were more general schematic images and concepts than detailed, accurate drawings with dimensions. The main real design tools of the master were a simple measuring rope, a compass for circles, a wooden square for right angles, and the construction site itself as a workspace. All design work took place directly on the site of the future construction, in full scale, which made it possible to immediately assess the scale and proportions of the building. Many key elements of the future building and its foundation were marked out in full scale directly on the prepared ground for accuracy. For this purpose, a large flat area with compacted soil was specially prepared, the so-called plaza or marking yard. On this special site, using wooden stakes and stretched ropes, an experienced master carefully drew a detailed plan of the foundation, the exact location of the columns, walls, and all the main elements. This full-scale layout allowed the future building to be seen in real scale and the necessary corrections to be made before construction began, which was much cheaper than correcting mistakes later. For particularly complex architectural elements, such as the elegant ribs of Gothic pointed arches or the intricate stone patterns of round rose windows, sturdy life-size wooden templates were carefully made from planks. Using these precise templates, masons then manually cut individual stones to the correct shape, checking the fit. This ensured with a high degree of accuracy that all the numerous details would fit together perfectly and join seamlessly during the complex assembly at great heights. Without such templates, it would have been impossible to create complex Gothic arches, where each stone had a unique shape and had to fit precisely into its place. The master builder was not only a designer and artist, but also a foreman who controlled quality, a calculation engineer, and a manager of materials and personnel logistics. Every day he supervised the work of hundreds and sometimes thousands of workers of various specialties: masons, carpenters, blacksmiths, diggers, and assistants. He was personally responsible for the timely procurement and delivery of huge volumes of materials from quarries, strictly monitored the quality of work on all sites, and promptly resolved all the inevitable technical problems that arose on the construction site. His word was law for all workers, and he was personally responsible to the customer for the result and deadlines. The invaluable knowledge of the art of construction was not passed on through written books or textbooks, which practically did not exist, but exclusively orally from an experienced master to a capable apprentice over many years of training. The secrets of the ideal proportions of buildings, proven rules for building strong arches and high vaults, tricks for working with various materials and stones, all of this was an integral part of the oral tradition of closed construction guilds and workshops. This professional knowledge, which gave an advantage, was literally worth its weight in gold and was carefully guarded from outsiders as a trade secret. Disclosure of the secrets of craftsmanship was punishable by expulsion from the guild and loss of livelihood. A master craftsman devoted to his work often spent his entire adult life, decades, on a single grandiose construction project, as the construction of a large cathedral could take 100 or more years, spanning several generations. Sometimes a father's work was continued by his talented son, who took up the same position and passed on not only professional tools and drawings, but also the grand design of the entire building, its concept. These outstanding people were both subtle artists with a sense of beauty and brilliant engineers and calculators, whose names, unfortunately, very often remained unknown to posterity and were not carved in stone. They worked for the glory of God, not for personal glory, which was part of the medieval worldview and Christian humility. It was these nameless geniuses of the Middle Ages, with their unique and rare combination of practical building skills, mathematical knowledge, and artistic sense of proportion, who were the true creators of the great monuments of medieval architecture that we admire today. They built majestic cathedrals not according to detailed drawings and calculations on paper, but according to an inner intuitive sense of harmony, beauty, and structural strength, based on the experience of generations of builders before them. Let's take a look inside the toolbox of a medieval builder. We won't find electric drills or angle grinders there, but we will see a set of simple tools that are perfectly suited to their task. It was their masterful use of this uncomplicated arsenal that allowed them to work wonders. The mason's main tools were a hammer and a chisel. There were dozens of types of hammers, from heavy sledgehammers for rough work to small mallets for precise fitting. Chisels also varied in size, from wide ones for leveling surfaces to narrow ones for carving ornaments. A compass and a square were used to mark stone and wood. The square allowed you to construct perfect right angles, and the compass allowed you to construct arcs and circles. With these two tools and a simple string, it was possible to construct any geometric shape, even the most complex ones. A plumb line, a simple weight suspended on a string, was used to check the verticality of walls. Gravity was the most reliable indicator, and the plumb line could not be wrong. This tool was indispensable when laying high walls and columns. The horizontality of surfaces was checked using a spirit level or water level. It was a simple wooden trough filled with water. The surface was considered horizontal when the water in the trough was level with its edges. Hand drills and augers were used to drill holes in wood and stone. This required enormous physical effort, but allowed for precise and accurate holes. A tube with abrasive sand was used as a drill for stone. Carpenters actively used axes and adzes in their work. The axe was used for rough woodworking, and the adze, a curved blade similar to a hoe, was used to level and smooth the surface. An experienced carpenter could level a beam almost to a plane state with a single adze. Of course, there were also saws in the arsenal, both large two-handed ones for sawing logs and small bow saws for precision work. Planes were also used for planing boards and chisels for hollowing out grooves. All these tools were made of iron and wood and were forged by local blacksmiths. They required constant sharpening and maintenance, but in skilled hands, these simple tools became an extension of the craftsman's mind and will. Medieval builders proved that it is not the complexity of the tool that matters, but the skill with which it is used. Their legacy is a hymn to human ingenuity, patience, and manual labor. They showed that complex machines are not necessary to create lasting value, but only a clear head, a keen eye, and a steady hand. We have come a long way from the forest to the spires of a Gothic cathedral, touching on the secrets of medieval builders. We have seen that behind every stone and every beam, there is no magic, but precise calculation, enormous labor, and a deep understanding of the laws of nature. Their technologies, which may seem primitive to us, were in fact perfectly honed to solve their tasks. These people did not fight with the material, but worked with it. They knew how wood breathes and how stone ages, and used this knowledge to create buildings that have been standing for 1,000 years. This is a harsh but important lesson for our era of disposable items and prefabricated structures. The history of medieval construction is a story of how limited resources give rise to boundless ingenuity. It is proof that the human mind has always been and remains the main construction tool. What other secrets of the past would you like to uncover? Suggest topics for future videos that you would like to see on our channel in the comments. And don't forget to subscribe so you don't miss out on new research.